This is Algebra 1, Unit 11, Lesson A, Combining Polynomials. After this lesson, you will be able to simplify polynomial expressions by combining like terms. So first, we're going to take a review a little bit on some vocabulary terms. So first, what we want to talk about is our constant. Constant is a number with no variable. It's a loner. In this example, 8 is the constant. That's because it'll always be 8 because there's no variable to multiply to change it. So 8 is constantly 8, so it is considered a constant, no variable. Next is coefficient. In this example, 2 is the coefficient because coefficient is the number in front of the variable. So 8 is our constant with no variable, and 2 is our coefficient because it's the number in front of the variable. Lastly, we have like terms. If you remember all the way back from the beginning of the year, like terms are terms with the same variable and exponents. So for example, 2x and 5x are like terms because they both have an x to the power of 1. But if I had 2y and 5x, those are not like terms because they have different variables. Likewise, if I had 2x to the 5th and 5x squared, those are also not like terms because they have different exponents. So like terms have to have the same variable and the same exponent. So new words for us. We're going to go over polynomial. Polynomial is a super fancy schmancy way of saying an expression with more than one term. We should say expression. An expression with more than one term. So if you see here, terms are separated by plus and minus signs. So this is our first term, second term, third term, and fourth term. So this would be a 4-term polynomial. And again, it's just an expression with more than one term. Next, we're going to talk about degree. Degree is the highest exponent. So this example is a polynomial to the 3rd degree. And the reason why it's considered the 3rd degree is because 3 is our highest exponent. We have 2, 1, and x to the 0, but those are not our degree because it's always the highest exponent. And lastly, standard form. Standard form means you're going to write a polynomial in descending order of exponents. So I start with my highest, and then I go to my next highest, and my lowest. They're in order. Descending means it's going from greatest to least. Descending order. Descending means going down. So we always start with the highest, and the rest are in order all the way from greatest to least. So let's take a look at example 1. Here we have 2 polynomials. They have 3 terms. So you can kind of see these are 3-term polynomials. Their degree is 2. So we're just kind of talking a little bit about some vocabulary there. Now, in order to simplify this, I want to get rid of the parentheses. But in order to get rid of the parentheses, I have to distribute what's on the outside. And as we know, if there's nothing on the outside, there's always a 1 creeping in the shadows. So we take that 1 and we distribute it. Now notice, 1 times 2x squared is 2x squared. 1 times x is x. And 1 times negative 5 is negative 5. Likewise, 1 times x squared is positive x squared. 1 times x is positive x. And 1 times 6 is 6. So really, when you don't have anything on the outside and it's positive, you're just going to forget about the parentheses. Now we're going to combine like terms. I always want to start with my highest exponent first. Since I have the exponent of 2, 1, and a 0, I'm going to start with my x squared. I then look to see if there's any term that can go with it. There is another x squared term. I'm now going to combine those. 2 plus 1 is 3x squared. Cross it off because I'm done with it. I'm now going to go to my next highest exponent. My next highest is x to the first power. I also can combine that with another x to the first power. They both have a 1 in front. 1 plus 1 is 2. Their variable is x to the first power. When you're done with them, go ahead and cross it off. And my last one, my constant of -5. I have a constant of 6. -5 plus 6 gives me +1. And this ends up being my final answer. And if you notice, it's already in standard form. That's because if I start with the highest and move to the lowest exponents, I'm already going to be setting myself up to be in standard form. Pause the video now as you try example 2 on your own. Press play to go over your answer. Make sure you pause the video, try it on your own. This is how we learn. 1 in front, it isn't going to change it. A 1 in front, it is not going to change it. And now that we're here, we're combining like terms. Highest exponent, it's like term. They combine to make 9x squared. Next highest exponent, like term, they combine to make -8x. And then lastly, my constants combining to make -14. Final answer in standard form. We're going to pause the video now as we take a look at number 3. Don't pause, just kidding. What we notice here is that I distribute the 1 to the first and it stays the same. But what's different about the next one is that I actually have a -1. And when I distribute that -1, it changes all of the signs. So again, take a look at that. You'll notice it changes all of my signs. So all of my signs are opposite of what they were before. And that's because of this -1. When you distribute a -1, it changes the signs. Now we combine like terms. 2x squared, -3x squared, make -1x squared. Notice how I don't have to write the 1. -x plus 5x is +4x. That's because this was a -1. And my constants, -4 and -3, make -7. Final answer. The most important part on this problem was distributing that -1 at the beginning. Pause the video now as you try example 4. Press play to go over your answer. Make sure you pause the video. Don't be skipping. You're better than that. So I distribute the 1. The parentheses go away. I distribute the -1. And I get the same thing, but with all of the signs opposite. Now that I'm here, I combine like terms. Highest exponent, next highest exponent, that makes -10x squared. Cross it off. Next highest with next highest, -11 plus 2 is -9x. Cross it off. And my constants, 2 minus 3 is -1. Final answer for example 4. We're going to take a look at example 5. The big difference here is now both parentheses have something out front. I distribute the 3, 6x squared plus 9. I distribute the -5, -10x plus 5. Careful with those signs. Same game, except for this time, my highest exponent doesn't have a like term. So it goes straight to the answer. When there's nothing to combine it with, it goes straight to the answer. My next highest exponent also does not have a like term, so it also goes straight to answer town. Lastly, we have our constants of 9 and 5, and that gives us positive 14. Here is your final answer for example 5. Pause the video now as you try example 6. Press play to go over your answer. I distribute the 2, 6x squared plus 8. I distribute the negative 6, negative 18x plus 30. I look for my highest exponent. I check for like terms. I put it in the answer. I cross it off. My next highest exponent, I look for like terms. Nothing to combine. It goes straight to the answer. I cross it off. Then my constants combine to make positive 38. Final answer. Pause the video now as you try example 7. Press play to go over your answer. Make sure you're trying it. Don't just be waiting. Distribute 6x minus 42. Now notice, this gets a little tricky because when you're distributing, we have to also consider the fact that this has a variable. Negative 4 times 2 is negative 8. X times x squared is x. I add the exponents to the third power. Negative 4 times positive 5 is negative 20. X times x is x squared. Again, you're adding the exponents when you multiply. Negative 4x times negative 1 is positive 4, and the x goes along for the ride. Now, looking for the highest exponent, negative 8x to the third, I check for like terms, I write it in the answer. My next highest exponent, I look for like terms, I write it in the answer. My next highest exponent, and it has a like term, they combine to make 10x. And my constant is at the end. Notice how all of these answers always have the constant as the last term. That's because it has the smallest exponent, because it's actually x to the 0 power. Pause the video now as you try example 8. Press play to go over your answer. I distribute the 2. I distribute the 3x times the 2x squared, and I get positive 6x. This is a power of 1, and it makes 3 when I add the exponents. I then do 3x times 4x. That gives me positive 12. X times x is x squared. Again, we're adding the exponents. And then I go ahead and multiply 3x times 3, and that's going to give me 9. The x goes along for the ride. Now I'm looking for my highest exponent. I have a 1, a 0, a 3, a 2, and a 1. 3 is my highest, so it goes first. There is no like terms, so it goes straight to the answer. And of course, cross it off so you know it's gone. Next highest exponent, check for like terms, put it in the answer. Next highest exponent, check for like terms. 2 plus 9 gives us 11x. And our constant by itself goes straight to the answer. Here you have it, final answer in standard form for example 8. This brings us to the end of our video. If you have any questions, make sure you ask them. Go ahead and begin working on the worksheet. Thanks for watching.